Okay, so this is a cellular wireless network question that's frequently been asked in most Didacom class or course, especially after you've gone through the course content. This is one of the questions that you might come across in exams or practical world or in the practical world scenarios. Okay, so to go over that, let's go to the question first to start solving the question. So the question is, you have a cell phone carrier that's been allocated 512 radio frequencies to operate. So it's like what you call it, maybe NCN or Vodafone or Airtel went up to NCA to subscribe for a license to operate a cellular service, and they were allocated 512 radio frequency channels to operate within. Okay? Within a given city. Okay, and they using their design for their cellular cells is in a hexagon form. Okay, so in a city with a hexagon pattern cell design, say continuing the question, says 12 of the frequencies is reserved for control channels, and each phone call uses 2 frequency call, which is standardized. Obviously, that obviously means that you do have transmission and receiving, or transmitting and receiving. They have to be on different channels to facilitate the back and forth transmission. So keep that every transmission that you have on most cellular networks have got 2 frequencies per call or per established connection. One is for transmitting, so send a message across, and then the other frequency is for receiving any kind of information that's coming back. Okay, so that's where you have the 2 frequency coming from. So in an advanced mobile phone service, use the frequencies distribution to answer the following question. Can I zoom in? Let me see if I can zoom in so you guys can read the question better or see the questions better. Is it better? Can you guys see the question?
Yes, sir.
Yes.
Okay. Good. So the first question they're asking you based off this scenario. So this is a scenario that you have. You have an ISP that got allocated 12. If you're yeah, if you don't have anything to say, just mute your mic. That's all. Eugene.
It's fine. I don't know how serious you guys.
This Eugene guy is annoying.
Can you mute him?
I don't think shit.
I'm trying to mute him and it's still okay. He's gone now. Okay. So the first question. So this was a scenario that you had. You had a scenario which states that you have an ISP that has been allocated 512 radio frequencies for a city cellular network of operation, and they implementing a hexagon cell pattern for their design. And within that 12 or 512 frequency being allocated, it's also stated that 12 of that frequency is reserved for more or less control channels to make sure we have better control of the channels that's been allocated, frequency channel that's been allocated for management, allocations of errors, managing accounting purposes and whatever. So that's the 12 frequencies. And also each phone calls uses 2 frequencies per call, which is standard for any cellular transmission. Okay. Now the first question is supposed to use information given, which is the frequency distribution that has been given to answer, I think about 3 questions over here. The first question is, if a pattern of cells has a reuse factor of 5, calculate the number of frequency per cell just for receiving calls. Okay, so now you can go back to your slides on cellular network, and you definitely see the advanced advanced mobile phone service formulas that are over there. They're within that slide. You can easily look at. Okay, so this for first question here is saying that if you have a reuse factor of 5, then calculate the number of frequency per cell just for receiving calls. First things first, if the ISP was allocated 512 radio frequencies and 12 is being reserved, it means that technically they only have 500 for most of their transmissions. Okay? Are we good? Guys, are we good? Hello? You guys mute yourself again.
Sir, you muted
Sir, we are
everybody.
good. We are good.
Yes, you are good.
Okay,
Sir, we are good.
great. So if you do have, so that means you are the carrier only has 500 radio frequencies to operate. Okay. So to identify, to calculate the number of frequency per cell that they actually have to operate within is just going to be 500 divided by 12, which happens to be, the 12 happens to be the number of frequencies. Oh, sorry, by 5, sorry. What am I saying? So they say it has a reuse factor of 5. So it means that it's going to be 500 divided by 5, because that's a reuse factor. Because if you do have 500 radio frequencies, then your reuse factor is 5. It means each and every 5 division should have, out of the 500, should be able to use that reuse factor. So in other words, the formula would just be the allocated or the operating frequency given divided by the reuse factor. Okay, you can look at the formula from your slides. So this will be 500. So the answer to this question here will be so answer will be 500. Now we're getting the 500 because 12, it was 512. We took 12 out for control channels. So technically, we only have 500. We actually have 500 to use for our business, for our frequency of our cellular transmission or operations. Okay. Now, if there's a reuse factor of 5, then it's just a matter of dividing that operating frequency.
Yes, sir.
By 5, by the frequency factor that we have, which will give you a 100, sorry, right? So it's 500 divided by the reuse factor. So your operating frequency Let me just put it into context. So it will be operating frequency. Yeah. Divided by
Yes.
reuse factor. Like I said, I'm getting these formulas from the slide, okay? Based off the advanced mobile phone service formulas that we have. So with that, you're definitely gonna get that will give you the number of channels. So this will give you the number of channels. So this represents the number, yeah, of channels channel frequencies, yeah, channel frequencies per cell for duplex, since every call has a duplex transmission, which is transmitting and receiving for duplex transmission. So you actually have 100 channel frequency per cell for duplex transmission. But I look at the question again, it says calculate the number of frequencies per cell for just receiving calls, not for transmitting as well. So if you do have 100, which corresponds to the duplex, which is both for transmitting and receiving, and you only want the receiving, it's just going to be divided by what? 2. So it's going to be 100 divided by 2 would give you 50, which will represent just a single transmission, In this case, receiving calls. So the answer to this question here is 50 frequency channel.
Send it tomorrow.
I don't have to.
So that would be the answer.
My own partner.
Okay. Did you all get that? Hello? Are you guys with me or not?
So we are here. Oh, we are here.
Yeah, I know you're here, but are you with me?
Yeah, we are with you.
Okay, so you got how I was able to get the correct answer for this particular question, or was able to answer this particular question, right?
Yeah.
It was pretty straightforward. You had 5, 12, 12 was reserved, so obviously you only have 5 to work with. And the question is asking for a reuse factor of 5. So per cell, so obviously you're gonna have to divide 5 by 5 to get the number of channels that you're gonna be using. Now each cell would be used this transmission. Since the question is asking for just receiving, you have to divide that number by 2. So it's actually 50 for transmitting and 50 for receiving. Okay? Are we good, folks?
Yes, sir.
So this would be your answer to this particular question. So we have 50 channel frequencies. Which represents just a single transmission. In this case, receiving. The next question is calculate the distance between centers of adjacent cell if the minimum distance between centers of cells with the same co-channel is 7 kilometers. So going back to the same rule, the formulas within the slide, so in this case, we have, there's D, which is the minimum distance. I'm just pulling this from your slides, okay? Minimum distance for co-channel. In this case, equals, they tell you 7 kilometers, km, right? Small d, which is your, small d, which is your distance between adjacent cells, distance between adjacent cells is what you don't know. That's the question they're asking you. We do know that the reuse factor N was obviously is a frequency reuse factor. Factor was what was it? Was it 5? Right, it was 5. And K, which is your total. I shouldn't put equal signs away. I should make this one dash instead. Yeah. So this is a dash because they actually are describing. So this is the total. This is your total system frequency that we had, which was the 512. Which was the 512, right? 512. 512. And we 12 was allocated, was reserved for control purposes. So the formulas that you have here to be able to calculate your D, which is the distance between adjacent cell, minimum distance between centers of the same cells. So the adjacent cells, which is your D, is what is missing. And the formula here is D, which is the minimum distance for co-channel divided by small d equals square root. Can I get square root over here? I need to insert a symbol. Let's pick up a symbol from here. The square root of n, which is your reuse factor. So that's the formula that you need to be able to calculate the distance between adjacent cell, which is the missing question or missing factor within this particular question. So let's plug in the values and see. We had D to be 7 kilometers divided by small d, which we don't know, or whatever we're looking for, equals symbol again, reuse factor of 5. So we do cross multiply, right? If you want to find D, we do cross multiply. which will give us D will stand by itself as 7. So you're gonna have 7 kilometers divided by 5, square root of 5, sorry. Square root of 5 should give you D, small d now, right? This is just simple math, right? So what will be the answer? What is 5 divided by square root of 5? I don't have a fancy calculator. Anybody got a fancy calculator to do the calculation for us? Productivity. Let me go to my fancy calculators over here. See if I can find the square root function. Okay, so the square root of 5 is 2.2. So if you take 7, sorry. If you take 7 divided by 2.2, you have 3.18. So it's 3.18 kilometers is the distance between adjacent cells. So this will be your answer to this question. Okay, folks, are we catching on? Yes, sir. Yes, sir. Yes, sir. Okay. So D happens to be 3.18 kilometers, or your distance between adjacent cells. Actually, it's 3.13. I'm guessing it's just, it seems you can even say 3.1, right? Because if you were to run it up, it's not up to 5 yet. So 3.1 is okay, 3.13, what have you, it's what you should be getting for this particular question. Are we good, folks? Are we following? Yes or no? Are we following?
No, sir.
Yes or
No,
no?
sir.
Yeah, we are following.
I
Yes.
heard somebody say no. Who said no? Okay, so moving on. The third question says, calculate the radius of each cell. And since we're using a hexagon, the formula is distance between adjacent cell equals to parenthesis square root of 3 times, sorry, times the radius as r. Since we already know what d is from the previous question, which is the distance from adjacent cell, we can just plug that into it, and that should help us find what r is. So in this case, it will be 3.13 divided by square root of 3. Square root of 3, which should give you your R. So that's equal to what? Do the math for me and see if you can get. So take that divided by square root of 3, and you have 1.8 kilometers. Are we good? Are we catching on, guys?
Yes, sir.
Yes, sir.
The third one is saying calculate the total area of a single cell, of each cell. So once again, you go back to the formula. What is the area of a hexagon? The area of a hexagon, if you Google it, is 3 times the square root of 3 times the radius, all divided by 2. Happens to be the area formula for a hexagon. Okay, so area of a hexagon is or equals 3. You can Google that. I just did, and I got 3 times the where is it? Let me insert the square root of 3. Square root of 3. And since you're using some, you separate them with your parentheses so you don't get confused up. Times radius squared, by the way. So radius squared, let's introduce a square over there. And all of this divided by 2. This happens to be the formula for the area of a hexagon. Okay, it says 3 times the square root of 3 times the radius squared, all divided by 2. Now let's plug in R, which we found from the previous question. So from the previous question, we can area of a hexagon cell of a single. The question is a single for or of a single hexagon. Single.
Just N before the G.
Yeah. Of a single hexagon. So A equals 3 times to parenthesis square root of 3, parenthesis close, times R, which is 1.8 kilometers. So it's 1.8 raised to the power squared, right? So 1.8 squared. All of this divided by 2. So now let's plug into a calculator and see what we can come up with. Let me see if I can. So I have, so I got 3 times the square root of 3 times obviously 1.8 squared. That gave me, so let me see what I got for that one. So I got 16.83 divided by 2. So the answer is 8.41 or 42 because it's 7, right? 417.
Yeah.
Okay, so 2 here. Obvious is going to be kilometer square, right?
Yes,
Right?
sir.
Kilometer square.
Yeah, it's an area, so it's square.
It's an area, so it has to be squared.
Yeah.
So this will be your area of a single hexagon cell for this question. Right, italic, this is supposed to be. I'm just trying to be too articulate, I guess, with my solution, huh? If you guys can do this for me, I would appreciate it. I mean, you basically, it makes, so when somebody goes through, they can easily see the progression in calculation. You state clearly, you know, how you arrive at every single value. And that's the way math is supposed to be solved, or questions like this are supposed to be solved. So anybody goes through, they can understand what exactly you're talking about, right? So you see how uniform it looks, guys? Nicely formatted and giving the various information that is needed to help you understand how the questions were and whatchamacallit. So if you over here, I can say that we got the 500. It was actually operating frequency is actually operating frequency. Actual, we use actual operating frequency. It's equal to 512 minus 12, right?
Yeah.
Which is your 500. Yeah, so now it follows suit. So you can understand how we got the 500. So you don't ask yourself, how did you get a 500 if it's 512 over here? Okay, so that's a typical question you would get within a cellular wireless network question or implementation or scenario. I think I'm getting tired, right? Everybody's exhausted. It's late. Anyways, so I'm gonna, since it's late, I'm gonna end it over here.